All right, so today we're looking at identifying equivalent expressions involving exponents. So if we look at these properties, it's going to help us solve problems that look like this. All right, so which expression is equivalent to 4 to the 7th power and then to the 1st power? Well, here are some properties, all right, some rules that we have to look at. Anything to the 1st power is that thing, all right? So if we had like 5 to the 1st power, that equals 5. If we had an apple to the 1st power, the answer is apple, all right? For the next part, it says a to the 0 power equals 1. So any number, a is just any number, all right? So whether it's positive or negative, as long as it's to the 0 power, it equals 1. An apple to the 0 power equals 1, basically, too. But an apple's not a number, so technically we can't do that. Next, we have a fraction, all right? A fraction using exponents, all right? And when we do this, for example, if the number is with the exponent in the denominator down here, then we can write it not as a fraction, all right, this way, but the power has to be negative. So for example, if we had like 2 to the 6th power, oh, we see the 6, there you go. The way to write it so that it's not a fraction anymore would be 2 to the negative 6th power. All right, so basically you reciprocate everything, but make sure you change the power. We also have two numbers, all right, that are the same, and they have different powers, and they're being multiplied. If it's the same numbers, the same base, all right, then that means you can just add the exponents. So for example, if we had 2 to the 3rd power times 2 to the 1st power, the answer is basically 2 to the, add the exponents, 3 plus 1, so 4th power. For the next part, if you're not multiplying, and let's say you're dividing instead of adding the exponents, we just subtract the exponents, all right? So in this situation, if we had 2 to the 3rd power over 2 to the 1st power, that actually equals 2 to the, have the exponents subtracted by each other, so 3 minus 1, so that's 2, all right? Usually when I'm asking if I ask you to evaluate, I would say go all the way through. So 2 to the 4th power, what is that? That's 2 times 2, that's 4. 4 times 2, 8. 8 times 2, 16. All right. Unless it says to leave it in the exponential form, then just leave it as is. So then what's 2 squared? 4. Next, we have the first, well, basically the exponential number. All right, we have it to a certain power. All right, if that's the case, then you have to multiply the powers. So if we had 2 to the 3rd power times, let's say 2, then it'll be 2 to the, what's 3 times 2, all right? Because I have 3, and then I have 2 here. That 3 looks silly, sorry. And so 3 times 2 is 6. And then just evaluate all the way through. Let's say that we have the same exponents, but for some reason it's actually different bases. Well, if that's the case, then you can write it as just the two bases multiplied by each other, and then you can bring it to the power, bring it to the exponent. I mean, if you don't want to do that and you just want to, like let's say we have 2 to the 1st power and then 1 to the 3rd power, or 1 to the 1st power, excuse me. This video is going to be long. 1st power. You can just do, 2 to the 1st power is 2, 1 to the